Let's now take a look on our previous problem where we have two vectors a and b, and they have the magnitude 6 centimeter and 8 centimeter, and the angle between these two vectors is 60 degree. Now we want to add vector a and b here using our analytical method. So first, let us imagine that we have an x-axis and y-axis, and let's put the x-axis like this. So the vector a is sitting on the x-axis, and this is the y-axis. Now we see that there's still one vector here that is not sitting at the axis, and we can see that the vector b here has a component in the x-axis, this one, and let's call this bx, and also the vector b here has a component at the y-axis. This is by, and we already calculate that if the magnitude of vector b here is 8 centimeter and this is 60 degree, so the magnitude of bx here is 8 centimeter times cosine 60, and cosine 60 is 1/2, so we get 8 times 1/2, 4 centimeter. And now for by, we can see that by is the opposite of this angle, so the magnitude of by is 8 times sine 60, and we get the value is around 6.928 centimeter. And now we can see that the idea of analytical method here is that we can add the vector which have the same direction. In this case, it's vector a and bx. So total in x direction here, we can say it's t. X is vector a 6 centimeter plus bx 4 centimeter, and that's equal to 10 centimeter. And here we only have one vector in y direction, which is by, and the magnitude is 6.928. So the total in y direction or ty is 6.928 centimeter. So now we can imagine that we have a vector in x direction which has the magnitude 10 centimeter, and we have a vector in y direction which has a magnitude 6.928 centimeter, and they are perpendicular each other. So to get the total of these two vectors, we can see here, and it's the diagonal, and since this is 90 degree, then the magnitude of this resultant is square root of 10 square plus 6.928 square, and we can get the value is square root of 148, or around 12.16 centimeter. Let us now take a look on this problem. So we have three vectors A, B, and C. And A has magnitude of 10 centimeter, and the angle here is 37 degree from x direction. And B has magnitude of 8 centimeter, and the angle here is 60 degree, and then C is pointing downward. So we are going to find the value of A plus B plus C. Now, if we apply the x direction like this and y direction like that, and you'll see that this vector has a component in x direction. So if you draw a right angle triangle here, you will get that A has AX and also AY. And also for BY, if we apply the direction for X here, this has BX, and then it has also component in y direction, by. But for C, we don't need to think about the components because it's already at the axis, which is it's at the y-axis. Now we can find the magnitude of the components. First, we can find the component here, Ix, and this is 10 centimeter and this is 37, so Ix is 10 centimeter times cosine 37, and cosine 37 is around 0.8, so you will get 8 centimeter. And now for AY here, because it's opposite of 37 degree, so the value is 10 times sine 37, and sine 37 is around 0.6, so you will get 6 centimeter. And now for BX, if you take a look here, BX, you can see that the angle here is similar like this, so this is also 60 degrees, so that's the opposite of 60 degree. And notice that the direction of BX is pointing to the left. So here we will have sign convention, so that the left direction will be minus 8 times sine 60 degree, and the value here is minus 6.92 centimeter. And BY here is pointing upward, so the value of BY is 8 times cosine 60, since this is the adjacent side of 60 degree, so the value here is 4 centimeter. And be careful when we work with this vector C, we should put minus sign here, because the direction is pointing downward. So let us now calculate the total in x direction. Let's call it Tx. First we have this component 8 centimeter, and then we have this component minus 6.92 centimeter, and we will get 1.08 centimeter for x direction. And now we can also find the total in y direction. Let's call it dy. First we have ay here pointing upward 6 centimeter, and then by plus 4 centimeter, and be careful, vector c is pointing downward, so we should put minus, and we'll get 5 centimeter. So here we have two vectors, that the vector in x direction Tx here is 1.08, and the second one is dy 5 centimeter. And in order to calculate the total of these two vectors, we know that we should make a parallelogram, and the diagonal of this parallelogram is the total. Let's call that t. And since Tx and Ty are perpendicular to each other, so that t, the magnitude of t is square root of Tx square plus Ty square. And let's put the number here, 1.08 square plus 5 square. And if we calculate the value, we will get it's around 5.115 centimeter. You can also find the angle here. Let's call that theta. So now we'll see that you have a triangle, right triangle here. This is theta, and this is ty, and this is tx. We can find the value of theta here using tangent. So tangent theta here is ty divided by tx, or theta is tangent. So you can find the value first. Divided by 1.8. And here we get 77.81 degree. So at this stage, I will finish the discussion about vector at here. There are still more discussion on vector, but we will get to those topics soon. Again, I would like to encourage you to explore these websites and get practice or play around with the simulation, so that you will get the idea how to do the vector addition.